Let's continue with chapter 4. Here we are going to have an example of the voltage divider. We have a series circuit. We have our voltage source to be 20 volts, R1 to be 15 kilo ohms, R2 be 10 kilo ohms, and they are asking what is the voltage across R2. So yes, you can go ahead and find the R total, then find the I source, and then multiply that I by the current, and then you are going to find the voltage across here. And we are going to do examples like that so you can see that it is the same answer, but it is easier if you use the voltage divider provided that says V2. The question is, what is the voltage across R2? So right here says the voltage divider says that the voltage across the resistor of interest is the resistor of interest divided by the total resistance of that branch, in this case the total circuit, multiplied by the voltage source. So the resistance of interest is 10K, the total resistance is 25K, multiplied by the total source, which is 20 total voltage, so we get 8 volts. Notice that 40% of the source voltage is across R2, which represents 40% of the total resistance. So that's how voltage gets split across the circuits, depending on what percentage that resistor represents as a whole part of the total circuit resistors. Let's do a voltage divider. Another example here, it says voltage divider can be set up for a variable output using a potentiometer. In the circuit shown, the output voltage is variable. So if we remember in chapter 2, we talk about potentiometers and what a potentiometer is. It is a variable resistor. So if we have a variable resistor, means the resistor can change. So if the resistor changes, then the voltage can change because the voltage is directly proportional, related to the value of the resistor. So in this case, my voltage can change, and we see this everywhere. If you are changing the music in your stereo, in your car radio, if you turn the knob, you are changing the resistance and therefore the voltage, and you can see that as changing the volume, going louder or getting quieter. If you're washing your hands and you open the faucet more, you get more water. If you turn it the other way, you get less water. So this is everywhere where we can see this phenomena. So right here, we can get a different value for V out depending on where the potentiometer is. So it says, in the circuit shown, the output voltage is variable. What is the largest output voltage available? So the largest output voltage available here, it would be the highest value the potentiometer can take. In this case, the potentiometer goes from 0 to 10 kilo ohms. So in order for us to find what is the largest amount of voltage, we would take the 10 kilo ohms. So we would say that 10 is half of 20. So it just makes sense that we get half the voltage as what 20 would get. So in other words, it is the same scenario as the previous one, where we know that, not that example, but this example, where we know that R1 is twice the value of R2. So in our case here, we would divide the voltage into 3. 20 will get assigned 2/3, and 10 it will get assigned 1/3. So 1/3 of 15 is 5. So you can solve it like that, or you can use this formula right here to solve for it, and you should get the same answer. Power in series circuit. Power in series circuit is going to be the same as voltage. You are going to add P1 plus P2, and that should be equals to P source. So the power also adds up in a series circuit. So power in a series circuit, use the voltage divider rule to find V1, V2, then find the power in R1, R2, and P2. So applying the voltage divider for V1, which is the voltage across this, it will be the value of the resistor of interest, 407, divided by the total value of the resistors. So it will be 470 plus 330. We get 800 multiplied by the total voltage source. That's going to give us the 11.75 volts. We do the same with the B2. We get 8.25 volts. Now for the power. For the power, I have the voltage and I have the resistor. So I can use the definition of the power of the version of Watt's law that says the power is equal to voltage squared divided by the resistor. So in this case, voltage is going to be 1175 divided by the resistor. I get 0.25. And then I do the same for P2 and I get 0.21. If I were to multiply, I were to do 20 squared divided by 800, I'm going to get 0.5 watts, which is the same as if I add 0.29 plus 21. So that's how power adds up in a series circuit. Voltage measurements. Voltage is relative and is measured with respect to another point in the circuit. So this is very important to keep track of what is it that we are measuring, because voltage doesn't mean anything if we don't have a point of reference. Voltage are given with respect to ground, are shown with a single subscript. So if we are giving a voltage from this point, from point B, we assume that that point, that value is with respect to the ground. If we are giving a voltage with two subscripts, that means it is a differential voltage between those two subscripts, okay? So voltages that are given with respect to ground are shown with a single subscript. For example, VA would be right here. Means the voltage at point A with respect to the ground, called reference ground, in this case to here. BV right here means the voltage at point B with respect to ground, which is here. Voltage VAB means the voltage between point A and B. So usually when we have a differential voltage, we have two subscripts, and what it means is that the first subscript is the first value, and then we subtract the second subscript. Like in this case, BA, it is 12 volts, because we are going to pick from here to the ground. So from this point, we can go across this and across that to the ground. Or we can say I can go across this other side, because there are two ways to get to ground, right? So if I go from here to here, what is my voltage? It's 12 volts, right? If I go, now how do I find BV? BV, I have to go from here to the ground here, where I can go from here to here to here to here. So it's easier to go from here to here. So how do I do that? I have to find the voltage across V2, which is going to be the voltage called VV. So use voltage divider. I said 10 divided by 15 times 12, I get 8 volts. I subtract them 2 and I get the 4 volts, which VAV is just V1. The voltage across the resistors number are R1. Don't worry, I'm going to do more examples later in this chapter so you can understand that. Voltage measurements. Ground reference is not always at the lowest point in a circuit. Assume the ground is moved to B as shown. If the ground is moved to B, then this becomes a completely different circuit, okay? Before BA was 12 volts. Now if we calculate VA, it's actually 4 volts. We go from here to here, from this point to that point. So that was actually only the voltage across R1, and we calculated earlier that that was 4 volts. So that's why VA is 4 volts. And then VV is just 0 because it's directly connected to the ground. So VV is 0. Now VC. Now this VC is from this point to that point. So, and that is going to be, we can either go from here to here, or we can go from here across that and across this to the ground. It depends how we choose to, but it was just easier to go from here to here. So in this case, we get that it is negative 8 volts. And in the next video, you're going to see how this negative 8 volts is that. What is, has AB changed from the previous circuits? VA, so VAV, no, it is the same. It is the same because VAB was just the voltage across B1, BR1, so that one doesn't change, so it stays like that. This is another example. It says assume that R2 is open for this case. What are VA, VV, and VC for the circuit? If R2 is open, then this goes off, and the circuit just becomes 12 volts and 5 volts. So VA would become 12. R2 is open, there is no current over here, so we just have noticed that VV is going to be 0. Because it is ground, and VA would be 0 because there is the same potential as B times B. BZ, it's going to be negative 12 volts because the source changes across the open source. I will write this example step by step so you can understand what is actually happening here. And that will be in our next video.